Okay, so today we're going to be learning about angles of elevation, angles of depression. So the big picture comes from this question. This chimney needs to be demolished by engineers. They need to know how tall it is. How can they find this out? Firstly, you're probably not going to want to climb up the side of the chimney stack, especially if it's not in good condition. These often have a ladder attached to the side, but the old wrought iron things could be 200 years old in the UK, and they start to get unsafe. So if they want to bring this down, they need to know how tall it is to do the necessary calculations for the how far the stack's going to fall, how much explosives they're going to use to bring it down. So it's important for them to do this. How would they work it out? Well, they're going to use trigonometry. So what you can do is you can stand about 100 meters away from the chimney using a piece of equipment called a theodolite, which is a very simple device that allows you to measure angles looking up or down. It uses a plumb line, which is just a piece of string hanging with a bit of lead on the end. Plumb is the Latin word for lead, plumb. So they measure the angle, and they find that the angle is 32 degrees. So how are they going to calculate this? So if you remember, we've got our angle here of 32 degrees. This is going to be our theta. Let's label our sides. That makes this one the adjacent. And this one is going to be the opposite. Three P's. Opposite. So doing our little triangles, we've got so, ka, to. And then labeling what we have and what we need. We have the angle, so we have the sine of the angle, the cosine of the angle, the tangent of the angle. We have this side, which is the adjacent. So we have the adjacents. And we are after this side over here, which is going to be the opposite. So we can see by our little triangles that this one is going to be the successful one. So the formula that we wish to use is that the opposite is going to equal the adjacent multiplied by the tangent of the angle. Putting in our values, that is going to give us 100 tan 32. Put that into the calculator. Just pull up my calculator. Here we go. Okay, so when you're using your calculator, often for a new lesson, press on, press 1 for a new document, say no to calculate, add a calculator, and then add anything else you need. For this one, we just need a 100 times tangent of 32. If you get an answer like this, press Control Enter, and then you'll get a decimal. So here our answer is going to be 62.5 meters. So this is an angle of elevation. It's called an angle of elevation because we're standing on the ground looking up, elevating. Use trigonometry to find the height of the lighthouse to the nearest meter. So most of these problems are going to be tangent problems. So in this case, we have the adjacent, we have the angle, and we are after the opposite. So that one, that you'll learn quickly, is TOA. We're after the opposite usually. So the opposite, which is the height, is going to be 62 times the tangent 33 degrees. Sorry. Let me pull that calculator up again. So 62 times the tangent of 33 degrees. Control Enter. 40.2. If you need a set amount of decimal places, press document 72. Let me try that again. Document 72. And if you scroll down here, fix means how many decimal places it's fixed to. So if we want to fix to 1 decimal place for this, and now when we press Control Enter, it will automatically round you. So that's to the nearest tenth. So we get 40.3 meters. Okay, so here for this one, we're asked to find the height again. So this is going to be the opposite, the adjacent, and we need the tangent of the angle. So the opposite, which is the height, is going to be 21 times tangent 45. Okay, I can save myself a little bit of time here. When it's 45 degrees, you should be able to do a shortcut. We've got our triangle here. This is a right angle, and this one is 45, and then this one is 45. So we've got a nice isosceles triangle, which basically means you're going to see that this is going to be 21 as well. Let's just try it on the calculator. 21 times tangent 45. 21. It's isosceles. So angles of depression are the reverse. So you're standing on a platform and you're measuring the angle as you look down. So Harry's standing on the edge of a cliff. He sees a boat. He wants to find out how far away the boat is. So he knows that the cliff is 40 meters high. He measures the angle of depression. The angle of depression is 25 degrees. What is the distance of the boat? So let's draw the triangle that we're looking for. So we are trying to find how far away the boat is. We want this distance here. We know this height here. But unfortunately, we only know the angle of depression there. However, the way that this one works is that this line horizontal to the horizon that we're looking from is going to be parallel with this line here along the ground. These are parallel lines. So if these are parallel lines, then this angle here is going to be alternate to the angle that we're given. So this angle here is also going to be 25 degrees. So now, if we label up what we have the opposite. We have the adjacent to find, and we all know the tangent of the angle. So just putting our triangle up. What we have this time is we know the opposite and the tangent of the angle, and we're after the adjacent. So the formula this time is going to be that the adjacent is equal to the opposite divided by the tangent of the angle. So that's going to be 40 divided by tan 25 degrees. Oh, sorry. Keep leaving the calculator up. All right, yeah. So hopefully you can see the two lines that are parallel. We can see where the opposite is, and let's make the calculation. Let me try and not leave the calculator up next time. So control divide, and we want 40, and then tangent 25. So the height this time is going, sorry, it's not the height, it's the distance. 85.8. So the distance is going to be 85.8. Okay, how high is the cliff? So it's known that the lighthouse here is 84 meters away from the cliff's edge, and the angle of depression is 30 degrees. So this line here, horizontal to the horizon, is parallel with the distance along the ground, which means that this angle here is alternate to this angle here. In this triangle, we have the tangent of the angle, we have the adjacent, and we're looking for the opposite. So I'm just going to pop up my formula like this. We are after the opposite. We have the tangent and the adjacent. So the height is going to be equal to 84 times the tangent of 30. We want 84 times the tangent of 30, which is going to give us 48.5. Okay, one last one. How far away is the boat? So we measure this angle here. This line here is parallel to this line here. So this line angle here is alternate. We know the height, we know the angle, and we are after the side. So this is the opposite, this is the adjacent. We want the tangent is equal to the opposite over the adjacent. We are after the adjacent, and we have these two. So the adjacent is equal to the opposite divided by the tangent of the angle, which is 38 divided by tan 39. Tan 39, Control Enter, 46.9 meters. Okay, little summary there. Angle of depression, we're looking down. Angle of elevation, we're looking up. That's it for today.